Good afternoon, everybody, my dear student. So, in the process of learning till now, we have learnt many things in our course of first chapter of chemistry, that is valency and molecular formula, and in that topic we have covered a lot, like from the beginning, like from the study of matter, that is chemistry. From that topic, through that we have studied lots of topic like atomic number, atomic mass, electronic configuration, radicals, etc. we have learned. So, today we begin from the covalent bond. Okay, let us revise it from there. So, first we have studied that why chemical bond exist between the different element. We have studied that the element come closer to each other to fulfill their stability or to have a stable electronic configuration, whether it is of duplet or octet electronic configuration. Okay. So, for that they come closer to each other to make it themselves stable. Okay. So, how they make stable? By forming the bond, the force existing between them. So, they are of two types that we have studied, that is ionic bond. In ionic bond, electrostatic force is acting between the atoms to hold them together, and in last class we have studied about the covalent bond, and the covalent bond is formed when there is sharing of electron between the atoms which are involved in it. Yes. So, after that we have studied about the types of covalent bond. Okay, in the last class we have studied, and they were how many types? So, they are of three types. Yes. So, we have studied. So, that are single covalent bond. What is single covalent bond? Okay. What is that single covalent bond? The bond which exists by sharing one electron each by the two atoms which are involved to make a compound is known as single covalent bond. And in that example we have discussed about hydrogen. Yes. So, hydrogen is one of the atom or the element which exists in diatomic form in the nature, and we know that what is diatomic element, isn't it? So, that element which exists in the form of two atoms as a stable in the nature. Yes, like in case of hydrogen, nitrogen, oxygen, okay, fluoride, chloride, like that. So, all these are diatomic element, and what happen in this hydrogen atom having one electron is, okay, they come closer to each other. There is no exchange of ions because they have they are both negative negatively charged, means they require electron to become stable. Okay, they are non-metal, both are non-metal. Okay. So, both are non-metal, they come closer to each other and they share one of their electron with each other and they form H2 molecule. So, that is the single covalent bond. Okay. Similarly, another example we can look here, okay, hydrochloride HCl. So, in HCl, hydrogen having one electron in its valence shell, whereas chlorine is having 7 electron in its valence shell. What happens? Hydrogen share its one electron with the one electron of chlorine atom. Okay. Thus, hydrogen complete its duplet, whereas chlorine is also able to complete its octet by taking or sharing the one hydrogen atom of one electron of hydrogen. Thus, octet is complete in case of chlorine and duplet is complete in the case of hydrogen. So, they are sharing one electron with each other. Okay. Thus, we can write as single dash Cl, that is HCl. So, that we have studied last time, that is single covalent bond. And after that we have studied about the double covalent bond. So, in double covalent bond, like in case of what we can say oxygen. Okay. So, in oxygen, both of the atom, two atom, they are sharing 2 electron with each other. So this oxygen atom also have how many electron? 6 electron in outer mesh shell, 1 2 3 4 5 6, and this also 1 2 3 4 5 6. Now each atom requires 2 electron to become stable. So what they will do, they will share. So this whole belongs to this atom and this also belongs to this atom, and thus O2 double bond O, that is O2 is formed. So in this way double covalent bond is formed between the atom to have a stable electronic configuration and exist in the nature independently. Okay. So like this triple covalent bond about the nitrogen we have discussed last class. Okay. So this is the thing which we have already studied, that is about the covalent bond. Now today's topic is what is polar covalent bond and non-polar covalent bond. So during study about the compound, we have studied that they dissolve in covalent polar solvent, and they are not dissolved in water, like that we have studied. Okay. So why what is that? So in that, while explaining that, you may have across about the polar, it is polar covalent, it is non-polar covalent, about that we have discussed. So there may be confusion. So before that we have to learn some terms to come across the formation of covalent bond, how covalent bond is formed or covalent compound is formed. So 2-3 point terms we should be clear of. The first point or the terms we will come across in chemistry is that of electronegativity. Electronegativity. Okay, this is the term frequently we will come across in chemistry. So that is also the factor which determine the type of bond which is formed between the atoms or the element. Okay, whether it will form ionic compound or covalent compound, it also depend upon this, and this electronegativity also contribute in the formation of covalent bond, either it may be polar covalent bond or non-polar covalent bond. So what is that? Okay, let's define it. It is the measure of an atom to attract shared electron towards itself. Okay, it is the measure of, measure means you have to measure quality, how much, okay, of an atom to attract shared, attract. So how, what is the quality, how much power while forming the covalent bond, which of the atom or the which of the element has a property to attract electron towards itself. Okay, sometimes you may find that you are sharing things with each other. Okay, you are sharing things with each other, but one of the person may be stronger than you. Okay, may be stronger than you, another is weaker, though both of them require help of each other. But sometimes what happens, some tendency has more power to attract itself. Okay, they have more power. So for example, if a very big dog and a small dog, both of them are having bones with single bone bones with them, and they want to share. So then what will happen, the one which is stronger, it has more capacity to attract that bones towards himself as compared to the weaker or smaller dog. Okay, so like that in formation of covalent compound also, if they are sharing the electron, okay, some has more power to attract and another has less power to attract electron towards itself, and that property which is called electronegativity. Okay, that is electronegativity. Okay, that electronegativity is the responsible for attracting shared electron. They are sharing, yes, both of them are sharing, covalent bond is there, but one of them will attract little bit electron towards itself as compared to other, because of its atomic size or electric charge or nuclear charge existing between them. Okay, so electronegativity increases from left to right, where okay, left to right. If you go in a periodic table, okay, you have studied in class 8 about the periodic table, okay, and in class 10 also you will study. So, here little bit I want to clear it, that when we move from left to right in a period. So, period in a modern periodic table, when we move from left to right, there are 7 period, okay, there are 7 period. So, this period, so along this period if you go from left to right, the number of cell is same, okay, the number of cell in each period is same. All the element which lies in same period, they have equal number of cell, okay, due to which as the element goes on increasing, as the element go on increase, if you move left to right, what happens, the number of electron increases, at the same time number of proton also increases. That means in the nucleus more charge is adjusted in a smaller area as the number of electron increases, okay, as the number of electron increases, the protonic charge or the charge at the proton or the nucleus is also increasing. So, due to which the electron is attracted toward the nucleus, okay. So, what happens when we go along the period, electronegativity means the power of attracting electron towards itself increases, okay. So, like lithium, electronic configuration of 2 1, okay, 2 1, lithium, beryllium 2 2, okay, having 2 electron, here 1 electron, positive charge at the nucleus is 1 3, and in case of this 4. So, due to which it attract more electron towards itself. So, it has more electronegativity. So, when we move from left to right, electric negativity increases, that means the tendency to attract the electron towards itself is increases, okay. That is it, okay, about this. And when we move from top to bottom along the group, okay, along the group, okay, like hydrogen is there and lithium is there, then sodium is there. So, if you go down in this group, okay, this is a metal group, for only to make you understand. If you go down, then what happens, the atomic size increases. So, if the atomic size increases, why? Because the number of cell increases. So, due to which as the atomic size or atomic radius increases, the nuclear power decreases, okay, to attract the electron which are lying at the valence shell, to pull it towards itself become lesser and lesser as we move downward. Same is there in the case of non-metal also. So, here we are studying about the non-metal. So, in case of non-metal like fluorine, chlorine, bromine, iodine. So, what happens? So, their atomic size goes on decreasing. So, hence electronegativity go on decreasing. So, this is a one of the factor which will contribute to study of polar covalent and non-polar covalent. So, I have told you that, and electronegativity should be 0 or negligible, means the difference between the electronegativity should be as far as possible, it should be 0 or very minimum or negligible to form a covalent bond, okay. So, this is one of the term you have learning new, that is electronegativity, okay, electronegativity, try to understand, okay. Now, next term that we will study is ionization potential, okay, ionization potential. This is also similar term. Here what is said, the definition, it is the measure of the energy required to move valence electron from the outermost shell. So, how much energy we have to require, or the atoms required to move the outermost electron from its outermost shell. So, that is called ionization potential, and it is also same, it is when we move from left to right, it increases. So, what happens when we move from left to right, the ionization potential increases, okay. And when we go down from top to bottom in a periodic table, it decreases as the atomic radii increases, sorry, it is increases. So, what happens when atomic radii increases? So, what happened, there is decrease in the ionization potential, because they are very far from each other. So, what due to distance more, so easily held together, they are held by less or weak force, and they can be easily removed with very much less energy. So, that is ionization potential. So, these are the terms, okay, which are new to you. So, try to understand, okay, carefully, and consult to your teacher about this. Okay, it is very new, and the thing I have told or taught you here this thing, because we have to understand what is polar covalent bond and non-polar covalent bond or compound. Okay. So, about the polar covalent bond definition, we can see on the board what it is written there. It is a type of covalent bond where a pair of electron is unequally shared. Okay, unequally shared. So, they are unequally sharing, they are sharing, both atom are sharing electron, but one of them is having more electronegativity as compared to other. So, it try to pull the electron toward itself, hence it acquires a slightly or a partial charge of electricity, that is negativity in it, and another one which is unable to hold that electron as firmly as compared to other one acquires the positive charge, and due to which two poles, one is positive and another is negative. Not like in the ions formation, we cannot say really ions, but partial electric charge is created, and that is called polar covalent bond, that is existed between HCl and H2O. Okay, that can exist in HCl, H2O and H3 other element, okay, that are polar covalent bond. For example, if you see here hydrogen and chlorine, just we have discussed it is a type of single covalent bond, but the size of hydrogen is very much small, okay, and that of chlorine is large. And what happened in this case, chlorine and hydrogen has a difference of electronegativity. Okay, it is lies in group 1 and it lies in group 7. So, number of charge, number of electron is here more, so nuclear charge is also more. So, here what happened, atomic size also smaller, though it has two cells. In hydrogen fluoride it is much easier to explain. Okay, in hydrogen fluoride both of them are hydrogen and fluorine having similar number of electron cell. Okay, so there you can understand, but in this case also hydrogen electronegativity is much less compared to chlorine. Then what will happen, this hydrogen electron is slightly tends toward the chlorine. Okay, they are sharing one electron with each other, but because the chlorine has more electronegativity, it tends to attract the electron towards itself and forming this as this partial positive, okay, and this chlorine partial negative. Okay. So, in this case this charge is created, and if two poles are created either positive or negative, that is known as the polarity or polar covalent bond, and the compound which shows this type of structure is known as the polar covalent compound. Okay. But in case of oxygen and nitrogen, which we have discussed, both of them are sharing equal number of electrons. Okay. Both of them are sharing equal number of electrons, as well as they are of same atoms. So, their electronegativity is also same. So, there will not be formation or there will not be pulling of electron by one atom towards itself than other, there will be equal. Okay. So, when covalent bond is formed when a pair of electrons are equally shared, then they are known as non-polar covalent bond. Okay. So, here we have discussed about the polar covalent bond and non-polar covalent bond. So, let us see the slide and try to understand the things which I have explained. Okay. Again I am repeating it. So, through the slide. Okay. Let us see the slide. So, first of all we have studied about the covalent compound. So, what is covalent compound? I have given definition there. So, you can read and write. The chemical bond which is formed by mutual sharing of electrons between two atoms is called covalent bond, and the compound formed by covalent bond are called or is called covalent compound. Example of covalent compound of having single covalent bond, okay, that is H2, that is hydrogen. Here hydrogen atom molecule I have shown, and at the dot structure or the structure also we have shown this, and here you can understand that single electron or valence electron of hydrogen, they combine with each other to form a stable electronic configuration of duplet and form a compound, and H2 is formed. Okay, and there H and H single dash is given, that is showing the single covalent bond, and H2 is formed. Okay. Now, next slide. In next slide we are able to see the single covalent bond with same HCl other than H2, okay, hydrochloride. Okay. Here element whose valence electron is different, but they are sharing same number of electrons, that is 1 electron each. So, in hydrogen atom only one electron is there, whereas in chlorine atom the number of electron is 7. So, here valence cell how much it is having 7, okay, and they share 1 electron with each other, okay, in HCl. In atomic structure you can see HCl is formed in that way, and in dot structure you can see in another way we can represent it HCl. So, H having 1 dot means 1 electron in outermost shell, and chlorine having 7 dot means 7 electron it is representing, and they are sharing 1 electron with each other, or you can write same thing as H dash Cl, that means 1 electron they are sharing with one another, and HCl is formed. Okay. So, this is the single covalent bond where two atoms or element are different. Okay. Previous one hydrogen they were combining similar atom. So, diatomic element were formed having single covalent bond, and in this example element having different valence electron, but sharing equal number of electron is shown. Okay. Now, in next slide double covalent bond which we have discussed earlier. So, double covalent structure is shown, that of oxygen equally sharing with electron with each other, that is non-polar covalent bond. Okay, non-polar covalent bond we can say, because in oxygen both the oxygen atom they are having 6 electron and requiring how much electron to become stable? 2 more electrons. So, here they are sharing 2 electron of each other to make octet configuration of themselves, and hence what happened? O double dash O, there O means representing the oxygen atom, and 2 line of different color, that means double covalent bond is shown there, and hence it is forming the oxygen molecule, and this oxygen molecule is an example of non-polar covalent bond, because they are equally sharing electron with each other, their electronegativity is equal. Okay. Both of them have equal tendency to attract electron. Okay. And now, in next slide triple covalent bond is shown, where nitrogen having 5 electron in its outermost shell, requiring 3 electron and sharing 3 electron with each other and forming a triple covalent bond, that is N2. Okay. So, triple covalent bond, and here also it is also a non-polar covalent bond. Is it clear? Okay. Now, if you move to next slide, if you see in next slide, we can find what is about the polar and non-polar bond or covalent compound, or polar covalent compound or non-polar covalent bond compound. So, here same thing which I have told, it is written here. So, it will make easy to write from there. So, what is that? Electronegativity, it is a measure of an atom's ability to attract shared electron to itself. Okay? And electronegativity increases from left to right across the periodic table as the number of valence electron increases. Okay? It is along the period, and down the group decreases when we move from top to bottom as the atomic radii increases. So, note, electronegativity differences between atoms should be 0 or negligible to form a covalent bond, or to show the polarity or polar covalent bond or non-polar covalent bond, that plays an important role. Okay? And in next slide, you can find about the ionization potential. So, what is ionization potential? It is a measure of energy required to remove the electron from valence electrons. So, that is in the case of ionic compound also we can find. And if both the atom have high ionization potential, if the ionization potential is very high, that is in the case of non-metal, both the element which covalent compound we are talking about, studying about, all they are both have more ionization potential. Okay. So, if they are having more ionization ionization potential, that means the tendency to give or lose or take is difficult. Instead, what they will do, they will share and form a covalent bond. So, that is why non-metal and non-metal, they are forming a covalent bond. Why? Because they have high ionization potential, means both requires more energy to remove the electron from its outermost shell. So, ionization increases from left to right across the periodic table as the number of valence electron increases, and it decreases along the top to bottom in a group. Okay? And in next slide, example of polar or non-polar bond. First, we are talking about the hydrogen chloride. In case of hydrogen chloride, both hydrogen and chlorine requires one electron each, but the electronegativity of chlorine is more than that of hydrogen. It needs to attract or it tends to attract electron towards itself. So, it is polar bond or polar compound is formed as a slightly positive charge is developed in H and negative in chloride ions. So, it is shown there. So, at the down, hydrogen has developed a positive charge, whereas chloride or chlorine acquires the partial negative charge. Why? Electron is pulled toward the chlorine. Okay? Because it is more electronegative. So, what it is? It is a polar covalent compound or polar covalent bond is formed between hydrogen and chlorine, because positive and negative partial, okay, it is formed there, not like in ionic compound totally positive and negative is not created, but slightly tendency to pull is of electron is there. Okay? And in next slide you can see of water molecule. Water molecule is also a polar covalent compound. So, this we have discussed many times earlier. So, I want to explain here. So, in case of water, hydrogen requires one electron, while oxygen requires 2 electrons to become stable. So, here oxygen requiring 2, they will share one electron with 2 hydrogen atom to make octet, okay, and hydrogen acquiring one of the oxygen atom forms a single covalent bond between the hydrogen and oxygen, but oxygen fulfill 8 electron by sharing its 2 electron with one each of 2 hydrogen atom. So, here if you see the down, oxygen has more electronegativity as compared to hydrogen. So, in both the cases it acquires hydrogen acquires positive charge and oxygen acquires negative charge, and the bond is formed, that is about the polar bond. Okay, next slide. Okay, next slide please. So, at last from concluding this, what we can say that non-polar covalent bond are a type of chemical bond where two atoms share a pair of electron with each other, while polar covalent bond is a type of chemical bond where pair of electron is unequally shared between two atoms. So, equally shared I have told about the oxygen and nitrogen, and unequally unequally where HCl and H2O. So, we have described about this, about the polar covalent bond or compound as well as non-polar covalent bond or a compound. So, this is the topic we have come across in this syllabus about this. A little bit is there. Okay. So, please try to understand, and hope you have understood what it is. For today it is already time over. So, we will study next topic in next class. For today, thank you very much. Stay home, stay safe.